Welcome to MRL. In this learning session, we'll study the areas of parallelograms. We know that the area of a parallelogram is it's the product of the base of the parallelogram and its height. So the area of the parallelogram is B into H. Now let us establish this formula in this particular discussion. Now what is given to us is ABCD, which is a parallelogram. We have to establish or to find the area of the parallelogram and establish the relation that area of the parallelogram is the product of the base of the parallelogram and its height, that is B into H. Now let us see how we can do that. Now area of parallelogram ABCD is equal to area of the triangle ADE plus the area of the trapezium EBCD. So that is ADE plus area of trapezium EBCD. Now drop a perpendicular CF to AB extended to F. That means we have one more triangle, that is BCF. Now if you look at ADE and BCF, these two triangles are congruent triangles by side angle side congruency criteria. Now let us see how it is. Now in triangle ADE and BCF, AD is equal to BC, opposite sides of parallelogram. DE and CF are equal, they are perpendicular distances between two parallel sides. Angle 1 is equal to angle 2 corresponding angles. Angle 3 is equal to angle 4 is equal to 90 degrees by construction, and the 5 and 6 angles are the third angles. Therefore, in triangle ADE and BCF, AD is equal to BC, DE is equal to CF, angle 5 is equal to angle 6. Therefore, by side angle side congruency criteria, triangle ADE and BCF are congruent. Therefore, I can replace triangle ADE by triangle BCF. Therefore, area of parallelogram will be equal to area of triangle BCF plus area of triangle EBCD. That means area EBCD plus BCF becomes the area of the rectangle EFCD. Area of the rectangle EFCD. And area of a rectangle, as we know, it is the product of the length of the rectangle into its breadth. Therefore, it is EF into CF. That is EF into CF. Now, what is EF? EF is equal to EB plus BF. EB plus BF into CF, and as we have proved that these two triangles are congruent, the corresponding sides are equal. Therefore, AE is equal to BF. So I can replace BF by AE. So I am replacing BF by AE. I get AE plus EB into CF is nothing but DE into DE. Therefore, AE plus EB is AB. Therefore, it is AB into DE. Now, what is AB? AB is the base of the parallelogram. If I take the base of the parallelogram as B and the perpendicular DE as H, then it is base into height, and that is base is B, height is H. Therefore, it is B into H. Therefore, the area of the parallelogram is base of the parallelogram into its height. So that is what is the relation or the formula to find out the area of a parallelogram. So please remember that. Now in this theorem, we'll prove that parallelograms on the same base and between the same parallels are equal in area. Now what is the meaning of this? See, we have two parallel lines L and M. There is a parallelogram ABCD and a parallelogram PBCQ, which are standing on the same base and between the same two parallel lines L and M. Now we have to prove that the areas of these two parallelograms are equal. That means parallelograms standing on the same base and between the same two parallel lines are equal in area. So now what is given to us? L is parallel to M, and parallelogram ABCD and parallelogram PBCQ are on the same base BC and between the same parallel lines L and M. Now we have to prove that area of parallelogram ABCD and area of parallelogram PBCQ are equal. Now for that, let us understand how to prove it. Now let us find area of parallelogram ABCD first. Area of parallelogram ABCD is equal to area of the triangle ABP and area of the trapezium PBCD. PBCD, that is the one. That means area of triangle ABP plus area of trapezium PBCD. Let us call this as 1. Now the area of parallelogram PBCQ is equal to area of the again triangle, that is DCQ plus the area of the trapezium PBCD again. So let us call this as 2. Now if you check these two triangles, they are congruent. Now how it is? Now AB and CD are equal because they are opposite sides of the parallelogram ABCD, and PB is equal to QC, again opposite sides of the parallelogram PBCQ, and angle 1 is equal to angle 2 corresponding angles, angle 3 is equal to angle 4 corresponding angles, and angle 5 and angle 6 are equal, that is the third angle of the two triangles. Therefore, in triangle ABP and DCQ, AB is equal to DC, and angle 5 is equal to angle 6, and PB is equal to QC. That means by side angle side congruency criteria, these two triangles are congruent. That means we find out that because of these two triangles are congruent, we find that the RHS of 1 and 2 are equal, because area of triangle ABP is equal to area of triangle DCQ, area of PBCD and PBCD are same. Therefore, that is area of triangle ABP plus area of PBCD is equal to area of triangle DCQ plus area of PBCD. Therefore, RHS are equal. Therefore, equating LHS, we find that the area of the parallelogram ABCD is equal to the area of the parallelogram PBCQ. So that proves that parallelograms standing on the same base and between the same two parallel lines are equal in area. Please remember that. In this theorem, we have to prove that the parallelograms on equal bases and between the same parallels are equal in area. Now, what does that mean? There are two parallel lines L and M. L and M are two parallel lines. We have a parallelogram ABCD and a parallelogram PQRS. Now, the bases AB and PQ are equal, that means AB is equal to PQ, and we have to prove that the areas of these two parallelograms are equal. Now let us understand the method of proving the theorem. Now, given L and M are two parallel lines, L is parallel to M, ABCD and PQRS are parallelograms on equal bases, that is AB is equal to PQ, and we have to prove that the area of the parallelogram ABCD is equal to the area of the parallelogram PQRS. Now, for that, let us drop a perpendicular DM to AB and SN to PQ. Now, the area of the parallelogram ABCD, which we already know, is equal to the product of the base of the parallelogram and its height. That is, area of parallelogram ABCD is equal to AB into DM. So also the area of the parallelogram PQRS is equal to the base of the parallelogram is PQ into SN. So therefore we have area of parallelogram ABCD is equal to AB into DM, and area of parallelogram PQRS is equal to PQ into SN. But we know that AB is equal to PQ, which is given to us, and DM is equal to SN because they are perpendicular distance between the same two parallel lines, and therefore the RHS of 1 and 2, that is AB into DM, is equal to PQ into SN. If RHS is equal, then we can equate LHS. Therefore, area of parallelogram ABCD is equal to area of parallelogram PQRS. So therefore remember, parallelograms on equal bases and between the same two parallel lines are equal in area. A very important parallelogram theorem which you have to remember.